So I think we're all familiar with this post about doing a 1 billion nested loop iterations with different programming languages to see which ones are the most efficient. And when I first saw this, I didn't really think much of it. I was like, okay, it's a cool little bit of statistics. Like nothing's really surprising. The languages like C, Rust, and Zig are at the top. Python's at the bottom. Go and Node are in the middle. I didn't think much of it. I was like, okay, cool. And some people had some critiques for it because you're not actually doing something. You're not actually solving a problem, right? You're just looping, and it's a way to benchmark something, but you're not actually solving a problem. So I thought to myself, like, how would I solve a problem? What is a contextual way to do things in different languages and then see which one is better? So, me being me, and my channel being what my channel is, I thought it'd be cool to write a neural network in 6 different languages, just a vanilla neural network in however the language's syntax would be, and then optimize it in ways that are specific to the language. For example, Go has Go routines and channels. C++ has the Pragma library, right? Things like that. So that's what this video is all about. I wrote a neural network in C++, Python, Go, Node, Rust, actually TypeScript, not Node, Rust, and Zig. So that's what this is all about. We're going to talk about writing the neural networks each language, what my favorite languages were, just little nuances about the language, and yeah, there are rules, so that way everything is consistent. There's no, like, the inputs are going to be the same in all of them. The input size to the neural network is going to be 5. The amount of hidden layers, or the amount of neurons in each hidden layer, is going to be 4. The output size is just going to be one output node, 2 hidden layers, a learning rate of 0.02, 1,000 epochs, and what we're actually going to be predicting is just the sign function, because every programming language has sign in their standard math library. So just 100, a data length of 100 just for sign, just a for loop up to 100. That's just taking the sign of the index, and then we're going to train it with 1,000 epochs and get a prediction. The prediction, or the code, isn't really about the prediction. The prediction will be fine. It's really just about how fast it takes. So we're going to hop right into it. I think the first language we're going to do is C++, and then we're just going to go down the list. I have it all already coded. I recorded myself coding it. I'm just going to commentate over it. It's in 4x speed, and then we're going to talk about enhancing it to ways that are contextual to the language. Hope you guys enjoy this video. If you guys like neural networks and like to trade, you guys should check out the collaboration I have with Luxago, because it's not your typical neural network where you have all your data, you split it up into training and testing, you train it, and then you test it, and then you put it out. It's a way different way to do it that can give you a better, nuanced approach to it. It's very hard for this model to be overfit, so the link is in the description if you guys like neural networks and like to trade. Back to the video. All right, here we go. So this is the first video that we have. It is the C++ implementation. And yeah, this is in 4x speed. It's still about a 10.5-minute video, just about writing out the neural network. If you guys have followed me for a while, you'd know that I actually posted this code already on my GitHub, how to write a neural network from scratch in C++. There's a few things that just aren't amazing about it, this specific implementation, because in the enhanced version, I kind of fixed one part of it, which was I didn't really use references too much when I passed around my variables. But I also think that there's barely any error handling in here. Use of asserts and stuff like that could definitely be good. I did change that actually in the enhanced version. I used references in the enhanced version. There's no use of asserts in here. And also, getting a random number from a real distribution makes the prediction just way off. I had that problem in the Go implementation as well, and that's actually when I noticed it, using a uniform distribution like that. I don't know why, but it just causes everything to not train right. But yeah, actually another set of rules that we need to know about the dimensions of everything. So we're going to have 3D weights and 2D biases. What does that mean? That means that every neuron has a weight and every layer has a bias. So the weights, as we'll see once I come back up to the private variables, the weights are going to be a vector of a vector of a vector of floats. And then the biases is going to be a vector of floats. So 2D and 3D for both of those. That is consistent throughout everything, because it affects how you have to loop through things. You would need 3 loops actually for the weights, because there's 3 vectors. So that's what we're doing here. Simply going through. I thought I'd feel like I had more to talk about, but we're about 2 minutes into this, and I already don't even really know what I'm going to talk about right here. I don't have a script, and I don't really want to script it because this is probably going to end up being a longer video. Yeah, I liked coding it in C++ quite a bit, but using actual good practices, typing out std : all the time, it can get very annoying. And I prefer. There's no good reason for this. This is just skill issues. I prefer to not code in languages where I have to use angle brackets, the greater than and less than signs, unless I'm doing greater than or less than. But that's just total skill issues. This this endeavor, also made me really actually care about learning Vim. You can see here that I'm coding this in C++. I am coding in C++, but I'm coding this on VS Code. Everything is on VS Code. Taking a sip of water there, apparently. I never really cared about learning Vim. I thought it would just want to be one of those things that maybe happened later on in my career. I think I should take the time and learn actually how to use it. But yeah, just one of those things. This is also something about the code that's contextual to what I'm doing right now, because right now I'm doing the forward pass through the neural network. This is pretty much just iterating through the neural network and getting the final output based on whatever the input is. That could be its own function. 100%. A forward pass should be its own function, and then predict should just call forward pass. But it is what it is. It's not really a big problem because you could just copy and paste it. So yeah. Also, as we go on and on, these little clips, I guess you could say, will get shorter because I'm gonna not code the entire constructor or the entire activation and loss functions every single time, because that's not the overall bulk of it. But yeah, shouldn't be too crazy. Right there, we just did our forward pass. We just got through all the hidden layers, and now we're at the output layer. And so now we have to check our errors, so that way we can actually backpropagate. Backpropagation is like, I know what I wanted, I know what I got, how did I get there, and then I'm going to update it based on learning rate and stuff like that. I found that when you actually take some time and you just check out the math for how it actually learns, quote unquote, how the weights and biases are actually updated, it's conceptually simple, right? To do it in the context like this of like coding your own neural network and stuff like that, it could get really annoying and difficult, but it could certainly, I don't think it's the hardest thing to grasp. If you do it enough, if you code it a few times from scratch, you'll think to yourself, okay, I'm on this step, so I know that I have to get my error and check it against the change in the weights of the other layers. Is what it is. You have to do K then J there. I did make that mistake with the Go implementation on the first one. I fixed it when I enhanced it, but yeah, it'll just mess up your prediction. So yeah, we're going through. Right now we are still doing backprop. We're almost done with backpropagation. Then we're going to do the predict function, where I'm just going to copy and paste it, but I messed up with the brackets, so it took a little bit longer than it had to be. There you go. Now that's all done. Yeah, that's the train function done. Do you guys like videos in this context of kind of commentary over something? Because it will be a longer video. I'm actually editing a little bit, could you believe it? But it's one of those things where I think it could be super entertaining, and I also think it could be super not entertaining because of how little I might be talking sometimes, because you can only explain and talk about a forward pass so many times, whether or not you're going through and you're doing it in C++, TypeScript, Rust, whatever it might be. But I think it could also just be entertaining to watch a time lapse like this. So that's also why I'm going to do it, regardless of how little I feel like I talk. Yeah, I don't know why I was having such a hard time with the brackets right there. Let's talk about my favorite languages to do this in. My favorite language to write it in was Go, right? doing doing it in Go right after doing it in C++, it was like sipping lean after rehab. It was so nice. I felt like I had to type so little in comparison. I felt like the LSP did so much for me, in terms of like formatting and just making everything nice. I quite enjoyed it. My least favorite language to write it in. Okay, we're not on Zig yet. Clearly, we're still on the first language. My least favorite language to write it in initially was Zig, because I wrote it like garbage the first time. I pretty much just copied the C++ code in Zig syntax. The first implementation I did was like 14. It took like 14 seconds to run, and so I got that output, and I was like, okay, it's me. It has to be me. There's just no way. And so I did what any CS college student would do and prompted an AI. I forgot which one I even used. Oh, you could put in a cert there, but it doesn't really matter. And you should also pass references. That's what we do. That's what we do to enhance it. But yeah, we're obviously going to talk about Zig more when we get to Zig. But yeah, I wrote it so bad at one point. One language One language that I did not think I would like, I just had an error in the constructor, and I couldn't tell what it was, so I just did that for my reference, just to make sure. Right, always have a reference just for something like that to happen. But one language that I wrote it in, and I did not think I would like it, but I did like it, was Rust. I enjoyed writing it in Rust way more than TypeScript. I have no desire to ever code in TypeScript. I really don't. Even just regular JavaScript. I don't know why I chose JavaScript or TypeScript over JavaScript, but it doesn't really matter. It's different flavors of the same cookie, I think. It's like a black and white cookie, right? Same cookie, slightly different on each side, but regardless, I'm just yapping. Yeah, so I do think I want to pursue Rust for more things because from this project I learned about Iced, just because I was just browsing around things contextual to Rust, and I learned about Iced, and it's so cool. I was always against using things like that, like coding in React instead of JavaScript, right? I was always against that contextually in my head. We're pretty close to it being over here. So if anything, I'll continue this thought in the next time because we're about to get all of our output. But I was always in my mind against like coding React because like it's JavaScript. But I don't know, man. I might have to change, might have to grow up a little bit because code like Iced is pretty close to JS, but like I mean Iced is pretty close to Rust. I guess that anything is pretty close to what it could be. Here's the output. There we go. So it took about a third of a second, or no less. Took 3/100ths of a second. So pretty dang nice. Let's get into the enhanced version. I did have a small error there at the end with the ABS function, the absolute value function, to see the error, but it's okay. I did fix it in the code in the GitHub because all this will be on my GitHub. It will all be all right. But yeah, we're going to get into enhancing this in C++ fashion. And so the way that we're going to do that is by better reserving stuff, like using references, better using memory, and also using the OMP library and doing pragma fors. So part of that is having, you could just say pragma for, pragma OMP for, and then your for loop will be ran in parallel. So that way it's not just one at a time, different iterations of the loop can be running at the same time. But part of that is having pragma criticals. So that way two things don't try to change the same variable at once. That could be pretty bad, could lead to output that we just don't want. Another little trick is to use an inline function, so that way the compiler has to do less. I didn't experiment with this, but I believe you could also do things along the lines of a G++ whatever file name -03, and so then it could be even better. But I had a bit of an issue getting that to compile, so I just stopped because I didn't want the C++ interpretation to turn into the worst part of this, which is a high bar, right? But yeah, I was talking about Iced before. I think I should learn that. Would you guys want videos about Iced? Maybe if I actually have YouTube videos for it, I'd be getting a bit better for it. But yeah, and here we're going to be reserving memory as well. And here we've got our output. Makes it a bit faster. Now we're consistently in the 2s instead of being in the 3s. So yeah, let's get into the next language. So here we are. The next one we're going to be talking about is Go. I didn't code the activation and loss functions because they're going to be the same for every single one, and I don't want every single one of these videos to be 10 minutes. So I'm going to do what we got to do. One thing I also did for Go, because Go's package system is so good, like with writing code in different files, was I actually did take advantage of it and put things in their own files. This is types, so we have types.go, and this is a neural network, so this is our constructor pretty much, because Go doesn't have classes. But yeah, I enjoy Go's syntax way more. If error not equals nil, it can get annoying, but I do like it. It's one of those things. I feel like also right there, don't use norm float. I changed that in the enhanced version, but yeah, it's one of those things. I don't like doing it all the time, but I'm glad it makes me do it. I'm not sure how much I would do it if I didn't have to, and it makes debugging way easier too. So yeah, we're actually already pretty much almost done with our initialize, which is very nice. I'm curious too. You guys let me know what your favorite languages are. And if you guys are really, really, really good in a certain language and I write one neural network like shit for that language, fork the repo and change it up, post it, say, Joe, you wrote this, you should have wrote this differently. And that'll be fun. That'll be cool. I wouldn't mind that at all. I encourage you guys to maybe even go through and make it a bit of a cooler prediction than just a sine wave. I chose that way it would be consistent throughout the different languages, just the standard math library. But yeah, could be cool to use something contextual, maybe a little bit more contextual to each language. Python, it's so easy to get data for everything, so could just use CSVs. But yeah, also you could upgrade it to have more than one output neuron. Could be cool. Could also update it to have more than one feature in the training process, right? Use a struct with multiple things on it, so that way your prediction isn't based just off of one thing. It is a bit easier for this because we can just predict sine with sine. Because this is a quant channel, we'll talk about trading a little bit. Because I find that a lot of people overcomplicate this stuff and try to make it into something that it's just not. It's just speed is very important when you do these things, and so having a huge bloated model that pretty much has the same thing just as a different number, you still have to scale them. So something that just has the same number, and what I mean by that is returns and like a moving average. It's kind of like putting a hat on a hat. I don't see the reason why. And because my professor put the gut feeling I had into an actual thing that can be supported with evidence, the law of large numbers would tell you that the bigger your training set and testing set is, the bigger your data set, period, the more accurate your prediction should be. And that is true for normally distributed things. We know that the market is not normally distributed. I will die on that hill. I will die on the hill of the market is not normally distributed. And so what that means is that law of large numbers doesn't necessarily apply. Just because I have more information doesn't necessarily mean that my model will be more accurate. Do with that what you will. Know what you're doing when you're making these kinds of models, because the context is so important. Context in what you're making it for. Like this sine wave, you could really go in circles, do a lot of different things, and it'd be fine. But for something like the stock market, or even something else that's just not normally distributed, you'll have to use different tools for it. You should use different distributions, right? sometimes those things can be really contextual. We're not really talking about Go at all, but yeah, the code is the same, just in a different language. But yeah, I prefer coding in Go so much. I really like how I make that struct and I can just say func and then give a pointer to the struct, and then it's like a method I could attach to it. Is it methods or functions in Go? It's functions. We could call the functions func. But yeah, let's also talk about, I'm going to talk about a little bit, because the video isn't that long, about how I enhanced the, oh, we're already on predict, about how I enhanced the Go neural network. The way I enhanced the Go neural network was batch trading with Go routines. So we would break up the data, right? I have 100, my data length is 100. So that's 10 groups of 10 of the elements, and that's all 100. And so train each batch of 10 on their own thread. Now, the results actually don't really suggest that that would be better. It is a little bit slower, but that's because I think that's just because the data size isn't very big, and I already recorded the C++ video with that input size, so I didn't want to change it. But yeah, it's one of those things where don't overkill it. I left it in there not being better to make this point of that you might not always want to throw the complicated thing at it. Like Go is a very fast language, especially for how expressive it is and how similar the syntax is to Python. In my mind, it is. I think it's very simple. So I think it's very impressive how fast it is, and I think that spawning unnecessary threads and just making something incredibly complicated for little reason might not be the best thing, and it could even worsen your performance. Not quite sure what happened to me right there, but yeah, small crash out. I forgot I put all these little messages. So yeah, we're going to see what the actual result is. And then later on at the end of this video, when we compare stuff, I'm actually going to show you guys what my hardware is. I just forgot that I didn't mention that. Here we go. We have 0.8, and there we go. So let's get into the enhanced version. If you guys noticed there at the end too, the prediction was way off. That was because of the, right there. Now the prediction is actually good because I had the wrong random numbers. So here we go. We're going to do some batches right now and then train them on their own Go routine using a wait group. And I think I used a channel. I'm not sure if I needed a channel. Yeah. So doing unnecessary things might not always be more efficient, even though on paper it should be more efficient, right? Like using a lot. It makes sense to think that using Go routine should make something faster, but not necessarily if you're already doing something that's not that intensive. You might just be creating unnecessary overhead. And also, I mentioned this before too, but at the end of the video, we're going to be talking about the hardware I have, because of course it'll be different based on whatever machine we're on. So that's all for Go. Let's go into TypeScript. Here we are with TypeScript. I'm going to finish that thought from last time. At the end of the video, the way that we're actually going to be talking about how long everything takes, because of course I'm just kind of cutting out these videos pretty much as soon as it happens. I'm going to be taking the average of me running it 5 times, and I'll show how long it is every time I run it. And of course I'm going to show what my hardware is, because that will of course have an effect on it. So yeah, now we're on TypeScript. I am not going to lie to you guys. LLMs helped me so much with this. I don't know any TypeScript syntax. So this was quite the magic show. I think everything felt a little strange. It confirmed for me that I didn't really like it. So it could be a good reason to do projects like this, to kind of know that you don't like something. And also, it doesn't really, in my mind, I don't think it makes sense to do something like this in TypeScript unless you already have like a gigantic thing written in TypeScript. That's the only way I feel like it could make sense. But yeah, we're going to be tapering down to more and more with how much stuff I have written already in each file. Most of the mains will end up being finished. the activation functions, like I said. But yeah, we're going through right now and doing this TypeScript. I'm also I'm compiling the TypeScript and running the TypeScript with Node, so that does matter. I'm not using Deno, I'm not using Bun, I'm not using Yarn, I'm using Node. So yeah, that'll all be attached to something, whatever I put in my GitHub and whatever I show you guys at the end of the video, that will show the actual performance of every language over like an average and over a couple different runnings. So yeah, we're going through. Pretty much just finished the forward pass. We just have to get the output layer. We have to get the output's actual prediction. So doing that right here. There it is. I'm still not entirely sure that like I get TypeScript, if that makes sense. And also, yeah, that error did not have to be there. If I just kept on writing, then it would have went away. But I'm still not entirely sure that I understand why TypeScript is necessary. I think it is skill issues just because I don't use it very much at all. I barely even use JavaScript. Maybe that's also my problem, is that I started, instead of trying to see if I liked this kind of writing code, I started with TypeScript, not with JS. But whatever, we're here. Maybe in the future it changes. I hope though. I hope so. But you could tell that I'm a backend guy. I think absolutely. So yeah, we're going through and we're updating our weights and biases. Yeah, nothing too out of the ordinary going on right here. I'll talk about how I enhance it a bit. The way that I enhance it is by doing a little bit of bash training and a little bit of SIMD, a little bit of single instruction and multiple data, sending it multiple, training like 4 things at a time. So it is a bit like batch training, pretty much in the middle. I really don't remember what I was going for that much, but it also didn't affect the runtime too much, and also making the code a bit more concise because it does have to get compiled. So a bit more lines, a bit less lines theoretically should help it run a little quicker. But wasn't very crazy at all, and went the avenue of doing just more things at once with this. There wasn't really too much stuff that I felt like was very TypeScript for me to do to this code. Like, of course, with Go, you could use Go routines. Of course, with just trying to think of a Python thing. But of course, with C++, you can use OMP, right? I'm not really sure which one there would have been to use in TypeScript. But here we go. We pretty much just finished the prediction function right there. So now we're in our main. We're getting our sign data, and then we are going through. And we're going to check out how efficient the TypeScript code is. It did surprise me how fast it was. I thought it was going to be way slower. I don't believe it was over a second, and I thought it would be over a second. The Python code is going to make you throw up after watching C++, Go, and TypeScript. But don't worry, we're going to get right back into Rust and Zig right afterwards, so it'll be pretty speedy. But yeah, Python took a while, but it's also kind of cool because you get to see the most improvements with Python. And I think that there are also, I didn't go that deep. I didn't go that deep with Python. I also think you could have done batch training. Well, no, we're going to get into that more and more and more, because Python has a little nuance when it comes to doing stuff asynchronously. We're going to talk about it a little bit. I don't want to be talking about TypeScript while we're talking about that. But yeah, we finished our main, so we're going to get our prediction, actual, and our error. Here we go, a little syntax error. So now compile it, run it, and pretty dang fast, 1/4 of a second. So let's get into the enhanced. Here we go with some enhanced code. This is going to be a pretty quick one because I didn't want to type it all out, but pretty much just making the code a bit more concise, using a bit better TypeScript syntax. I think I'm not very familiar with it. I'm not going to pretend like I'm an expert on it. But yeah, this confirmed for me that I will not be learning TypeScript anytime soon. So yeah, we're going through. We can see that we're processing 4 elements at a time, and that we're going to implement a bit of a batch trainer right now. I don't actually use like an async keyword, so it is closer to SIMD than anything. And also, we're just doing actually using verbosely using gradients and stuff like that. Like actually telling you that it's a gradient and shit like that. Shouldn't really change output too much because at the end of the day, it is like that partial derivative. It is that gradient for however you implement a neural network. So shout out LLMs for making this portion of the video possible and confirming for me that the languages I want to pursue further. But yeah, here we go. Almost done with the predict function. If you guys remember last time, it took about a quarter of a second. So let's check out the difference. I think I have to change a few things in main. Yep. So here we go. Little crash out. I'm not sure what I'm looking at right here. Oh, okay, we're good. Still about a quarter of a second. So yeah, let's do Rust next. I lied. We're doing Python next. I want to end with 2 fast languages, so we're gonna do Python next. Honestly, the most annoying part about coding it in Python was the dang thing going up at the top, showing up at the top right there. One thing about Python 2 is that kind of the whole point of this is to use strengths that different languages have to actually not just compare the languages as vanilla languages, because then of course things like C, Rust, Zig, they'll always be faster. But part of it, I wanted to use language strengths. In my opinion, that means using NumPy with doing it in Python. No, it's not the standard library, but it's one of those things that I think it's close enough. I really do. Is it technically the only dependency in this video? Yeah, but I think that it's fine. I think that we could get away with it. One thing that I loved about coding in Python is the damn list comprehension. Oh, let's get into part of the Python enhancement. So Python has something called the global interpreter locker. Now, what that means, well, let's step back for a second. When we click run on a Python program, right, Python run main.py, what happens is, for anybody that doesn't know, what happens is our Python code gets interpreted to bytecode, and then that bytecode gets ran, and that's actually what causes things to happen. Python has that GLI, or GIL, that global interpreter locker, and so what happens is that bytecode can only get ran synchronously. We can asynchronously interpret stuff, but only synchronously run stuff. That's why, like, if you guys watched my Quant Finance Advent to Code, when we would do parallel backtests and they would come out in order, that's why. We're still doing stuff asynchronously. It is still faster because of that, but that GLI is a huge performance overhead. Does it mean that Python's good or bad? I have no idea. It's just a thing about the language. So yeah, we're going through here, and we're on the train function already. I got so caught up in talking about the global interpreter locker. Are we almost done? Oh no, we're finishing up the backprop right now. Or we're in the middle of backpropagation. But yeah, list comprehension in Python was definitely my favorite thing about literally typing in this. It was very slow. And also one thing that was funny, because I wrote this stuff pretty much back to back. I think I spent 2 days on it, on writing everything out. So typing out error and then ERR, because some languages have error as a value. It was kind of funny. The funny thing I noticed. One thing too, because this video is just all over the place, so why not talk about something else? Is coding with AI. I think a video like this is a perfect use case for an LLM, because I initially wrote a neural network from scratch in C++ and Go. You guys can see them on my GitHub already. And I already did it for the Quant Finance Advent to Code as well. I didn't need another lesson about neural networks, but I didn't know TypeScript. Perfect use case for an LLM. That's what I think. To talk more a little bit about coding with AI, I think that the worst thing it did for me, the worst impact it had for me as I'm currently a junior in college, is that it greatly altered how long I thought things should take. Things can take way longer than I thought, right? But just using an LLM, you can get an idea out very quickly. And I think that is good and bad, right? Because now I can think in a way that's more creative than in a way that is more, I don't want to say closed off because you'll understand limitations more, but something along those lines, right? In the sense of I might have an idea that I might not have if I more intimately understood the limitations of each language. You should feel like you could accomplish anything in each language, but I think that you guys would understand what that means. I didn't put absolute value there also, but it's one of those things where when you don't need another lesson on something, it's a great thing to do. Like a few people asked me how I did the quant finance having to code videos so fast. I didn't need another lesson about the Hurst exponent or about using some of these different APIs, even about making a parallel backtesting system. So if I ever got stuck on how to do something the Python way, just looked it up because I understood what I was actually trying to do conceptually, did that on other languages before. I wasn't going to let the fact that I was using Python make that take longer. I don't know why I was having so many errors, but there you go. And there it is. We'll call it 3.8 seconds. So let's see how much we can shave off of this. So this is probably going to be the quickest enhancement portion of this video. What we did right here is change the things to be an async function. So I couldn't catch how much that sped things up, but making async, train, predict, and main functions, and just using await and async IO to run them. And here what we're doing, we changed that to static methods. I just hovered over this, that way you guys can see that for a second. And we're also specifying more and more what we want each thing to be and what we want it to return, and also using tools better. So we have np.dot there to do dot product for us instead of actually having to type every little thing out. Could make compilation a little faster. I'm not going to spoil how quick it got because almost done. Shouldn't take too much longer. Here we go. Shaved about a second off, a little bit more than a second actually, which not terrible. Still over 2 seconds, but not terrible. Here we have the Rust implementation. I liked coding in Rust. I'll admit it. I liked this. I like how things were const by default. I enjoyed it. Yeah, I really did. I don't know what else to really talk about with that. One thing I did not like was having to use dot map, and then I also don't like having to type out the pipes unless I'm typing out or. It's the only time I want to have to write that out. Also, another little nuance between languages right here. Will I have random.generate and then 2 times 2.0 minus 1.0. Needed it for the accuracy. Not quite sure why. Really, might be maybe someone who's better than me at Rust would be able to explain that better. Why it would make sense to do the time 2.0 minus 1. One thing I really did like about Rust was right there, if you just need to loop through something and you don't care about the thing you're looping over, you just need it as like a range. For underscore in start dot dot, whatever you want to go up to. I like that. I like that a lot. Scratched my head right. But yeah, we're going through it here, and now we are at our train function. We finished up our initialize, now we're at training. I liked having to specify mutable or not. I thought it was intuitive too for my brain. Right, the only language I did after this was Zig, and so typing out const all the time in Zig afterwards was annoying. But I liked it, and I think it was easy for me to pick up, regardless of all the languages that I did before. Like, it didn't really bother me too much. These dang one-liners, though, I also didn't have an LSP for when I coded it in Rust. You can see there the Rust analyzer, it just has a big error through it. I thought it was working. I genuinely did. At the end of it, I had so many errors at the end of it. And at the end of it, I was like, when I was debugging it, I realized somewhere in all this, I realized I didn't have the actual LSP on, so I was just, it was only VS Code helping me out if I already had typed out a word. But yeah, that was annoying. That definitely was annoying. But what are you gonna do? I also think it was a bit better too because not coding with an LSP is good sometimes. Is good every now and again. Get those fingers loose. Get yourself really thinking about what you're trying to do instead of something just finishing it for you. Even though it could be good to have something finish it for you because you could think faster, keep on thinking. But yeah, whenever I think about coding with AI and like making a case for it, having my take, ultimately, after whatever I say, I end up thinking to myself like, still probably would be better off not using it. Like I said, as a tool, when you've already done a million different things, and when you've already done something a million times, you don't want to do it the millionth first time. Makes sense. When it's just something really annoying, but you understand it. Like the other day, I had to code a Newton-Raphson step. So annoying. So I just had AI do it for me, and it was not that hard. I didn't have to debug that much of it. Generating boilerplate code, great, because that's annoying stuff that we don't want to think about. Things like that make sense, but just not at all knowing what you're doing and just thinking, write me a neural network in Rust. And you don't understand what's going on with the actual neural network. That's not the best. Even if you don't understand as intimately why it's .enumerate.map, whatever, I just chose that because it's right there. Even if you don't understand that as intimately as someone who's an expert at Rust, you could get away with it, but learn it still. Like, it's okay to get away with it at some point if you actually learn it later. They're tools for us to get better, not tools for us to just crank out code. Like, are you just a code monkey? Like, no, I think it'd be more fun to be an engineer, personally. So I wouldn't want to be limited by my access to an LLM to be able to be effective and make something that I think is beautiful. All that malarkey about do things that you think are beautiful, it's not malarkey. Make stuff that you think is beautiful. I think that neural networks, I think the math behind it, I think it's gorgeous. So there's my take on it. I'll leave it at that. Can you tell I'm just kind of reaching for things to talk about a little bit? I didn't have a script. And I didn't have a script for this reason. I want to talk to you guys like you're my friends, like you're right here with me. I want to read the comments that you guys leave. And because I think that there's a lot of people out there who are smarter than me, just as smart as me, but they might not have the audience like I do. For whatever reason, I have 2,000 followers on YouTube now. Thank you so much for that. I just realized I wasn't full screened. So thank you so much for that. But I think that if you guys, like, it's still a way for you guys to all converse with me and converse with each other, right? Kind of like one big hub where a bunch of quants can come along and talk about making neural networks in Zig, right? It's cool. So I encourage you guys to talk to each other and give feedback. Talk to me and give feedback for stuff in the comments. But here we go. I'm just debugging this this Rust right here, because a lot of it is like right there. I typed out layer underscore layer. So of course that would just break everything. Name that variable wrong. Right, just silly stuff like that. I just copied and pasted that for my reference because I didn't know what was wrong. I used the wrong self right there. Something with .collect. One thing I do like too is I like how detailed Rust's error messages are. Oh, that was why it wasn't. It didn't look like it was full screen because I had to open up my terminal. Yeah, for some reason my VS Code doesn't believe that I have Rust installed, even though I do. So I just would run from the terminal. Doesn't matter. We are almost done with this. Oh, 2 seconds right there. And I changed that to make the compiler happy. So there we go, 2 seconds. So don't mind showing the errors. Let's get into how I enhanced the Rust code. Here we have the enhanced version. So in the vanilla, that's what we just showed right there. It was actually 1 second, so a bit faster right there. I'm not sure what the discrepancy was, but again, we'll see it in the table at the end of the video. But yeah, we're going to be doing batch training again for Rust because like Tokyo and just async functions, it's pretty good in Rust. I like it a lot. So we're just gonna again play to the strength. We're not gonna try to do something weird. I'll talk about this now, even though it's the next thing. But for Zig, I went with SIMD instead of what are we doing right here? Went with Zig and went with SIMD instead of batch training just because I didn't want to do it again, and because threads in Zig, because it's so new, I'm not sure it's what I would want them to be. I did not look into it very much at all. I just kind of, it's just new. And one day I was watching the Primogen, and he was talking about how he would have to write his own threads. So I just took that as just make it go with a simpler route. But here we go. Pretty much already finished that. So just checking out the errors right here. Not sure what that was. Oh yeah, I had to make the first function or the main function be the async function, the access. So there we go. In the enhanced, third of a second. Not bad at all. All right, so let's get into the last one, which is Zig. Here we have the sixth and final language, which is Rust. Yeah, like I said earlier, I wrote the first Rust code terribly. It was pretty much just a straight up copy and paste from the C++ code. So I did use structs and stuff like that, and it was just incredibly slow. It was like 14 seconds for me to run it. Also, a little nuance right here for Rust is that, not Rust, for Zig, was that scalars helped so much with the prediction accuracy. Not entirely certain why. I didn't really investigate that much into it, but yeah, they helped so much, and so I kept it in there so that way accuracy would be preserved. It does. I don't think it would take. I don't think it would take that much longer to increase runtime. So, is what it is. But yeah, at first I wrote that Rust or the Zig code so terribly, but it's okay. Fixed it up a bit, and we're here now. Shout out LLMs for TypeScript and for Zig. But yeah, a few things that were weird for me to get along or understand with Zig was I got so many type errors that it wasn't what it was looking for, and using the at as and at like from float from int, it was a little weird for me to get behind at first, but it's not actually a different concept. It just felt strange at first, but I don't think it's very bad. I'm also using my mouse heavy in this, right? I'm using my mouse and I'm using VS Code. I wonder how many people are still watching. um, maybe eventually I learn actually try to get good at Vim or something like that, or NeoVim. I don't know. Maybe I just make my own. Maybe I just use Iced and then make my own. Be on the lookout for that. That is not priority at all. Like I spoke about in the last episode, that is not priority. But I really want to do it. Regardless, though, we're still coding in Zig right now. So we're starting off our training function. So we're going to get our forward pass. And yeah, like I said before, when I do enhance this code, it will be with SIMD. So yeah, a lot of changes are probably gonna, a lot of changes are gonna have to happen, but shouldn't be too wild. I don't remember how much the increase was, but again, we see that syntax of like for whatever dot dot the limit, and then a pipe, and then whatever we want the actual iterator to be. Yeah, weird to get rid of, weird to get used to. I think I forgot to do my output right here, so I had to go back and then do my output after this. Yep. I just kept on going. I just kind of ignored it, I think, right here. And then continued. Nope, I did it right here. So, yeah. I don't think that any of this code looked that different. I think that the TypeScript code was the starkest difference in terms of just literally looking at the characters. I feel like everything else is quite similar. Yeah, my favorite language to do it in was definitely Go. My favorite language to type it in was probably Go, Python, C++, top three. My actual favorite languages to use was probably Go, C++, and Rust. Go, Rust, C++. I like Rust's cargos better than using C++ external libraries. But yeah, still cooking through in Zig. I feel like if I spent a lot of time with Zig, I would really like it. But I don't quite see the reason why at this point in my life right now. Maybe when Zig gets a bit more mature, but yeah, not really entirely certain. But we're finishing up our back propagation right here. Remember K then J right there. That's a neural network thing, not just like a specific programming language thing. Oh, I forgot to talk about this as well. Is that in some of the languages, I would have flags for like if we're on a specific layer or not, because it would mean that we're on the last one or on the first one, and we would want to handle that differently because they would be a different next step. So that's what we're doing here. We have that if and then that else. Um, yeah, just a little thing to make it a bit more concise. And here we are copying and pasting the forward pass because it's the same thing. Yeah, I believe that is all. Oh yeah, I have a few little errors right there with these brackets. I believe it was the brackets that was messing everything up, and the indentation was throwing me off a bit. I'm not sure what this error was. I think it was just with the brackets, and just had one out of place with the copying and pasting. I don't mind showing these errors really at all, because if somebody tells you that I think this was an Elon Musk quote. If someone says that they coded something for a Stripe, don't believe them. Something along those lines. There we go. Yeah, sometimes coding could be very difficult, but that's okay. One thing about Zig too that I kind of ignored was the ability to specify if something was compile time or runtime variables, and that's pretty cool. And I didn't use that at all in the first iteration, which is probably why I was so slow. But definitely a cool thing to be able to have that kind of control. But we have it. So a cool thing about Zig, I suppose. Um, yeah, here we are. We're just finishing up our training, and then we're going to get our prediction, and then actually get our our runtime. I did do it in seconds, not in milliseconds or anything like that. I chose it, right? I remember the Windows kid wanted to do it like that, and I didn't notice that I left all that in there already. So I think I typed out a lot of unnecessary stuff. And then I'm sorry if you just heard me, but yeah, I wonder when I noticed it. There we go. There we go. There I noticed it. So here we are. Oh, I have one error right there with from flow from int. There we go. Little issue with the looping, I think. Oh, passing a reference or not. There we go. Oh, one last thing. It's also not good to do these things when you're in a rush or something like that, because, or after you do a lot of them, because you'll just want to get done and you're not even thinking about what you're doing, and then you'll make stupid mistakes like that. But yeah, just going through and changing the last things here before it'll actually run. I'm not even sure. What is this error? It was an index out of bounds. Okay, probably just yeah. I just reran it like I didn't like just looking at it would fix it. I'm pretty sure it was something in the initialize if I remember correctly. I don't remember, but it might be something there. I'm not sure what that was then. Okay then. 0.8 seconds. So let's get into the enhancement for it. Here we go. We're going to be setting it up for SIMD, or single instruction multiple data, if you're not familiar. But yeah, so we just have to change up our start a little bit, so that way we have consistent sizes, just hard coding some stuff just for simplicity. But yeah, setting up so that way we could train with a vector of length 4 instead of train with vectors of length 4 instead of just whatever we're on. Like each index will be a vector. And we're also having our a vector dot product function to make things a bit more suppose you could call it idiomatic. Is that the right thing for this? Is that the right word for this? I suppose. Splat gave me a lot of issues as well, but a bit more concise, a bit more. Not sure what the word is to make your own vector. A bit less of repeating myself, I suppose. But yeah, going through here and doing some vector dot product, so that way we can have vector dot product. You need that for neural networks. We were doing it from scratch before every single time. I'm not sure how much of this I copied and pasted. I hope a decent amount, so that way, because this video, I don't want it to be too long. I think that people will enjoy watching coding time lapses, but I'm not sure how much they would enjoy hearing me yap about a bunch of stuff over and over again. Oh, I did put a lot of, yeah, I'm even just letting it stew there so that we could pause and read. This will all be in my GitHub as well. But yeah, did do a lot of copying and pasting, which is good though, because I don't want to have you guys all here all day. But so yeah, that is it. That is changing up everything to be ready for some SIMD. So now we're going to go into our main, and we can just use Zig build, and this actually tends to be about the same or a bit slower, in fact. So goes to show again, don't use unnecessary stuff. But now let's get into however I decide to organize this stuff, so that way we can see the average and how long each thing actually took next to each other. Future Joe here, I forgot to mention what my hardware was, so I'm going to do that now. I'm going to read it out. I have an Intel Core i9-10980HK, 2.4 gigahertz to 3.10 gigahertz, 32 gigs of RAM, and yeah, 64-bit Windows 11 is what I'm running. I know he's running Windows! I'm not starting a virtual environment just for this, and I bought this a while ago. It's an Alienware M15. I love it. So yeah, back to the video. So here we have all of our results. We can see that C++, and then Go, Zig, TypeScript, Rust, and then Python. See the same results for the enhanced, because honestly, we saw a lot. Like Go is a perfect example. Actually got slower. TypeScript, the average got slower. And the way that this is 1, 2, 3, 4, 5 runnings, and then just the average of it all. So that's actually what these represent. So we can see that Rust and Python probably got the most noticeable increases. Rust got the most noticeable increase or decrease in time, most improvement. And then everything else pretty much stayed the same. C++ was pretty much around 0.2 every single time. Go was pretty much around here every single time. TypeScript really surprised me with how fast it was. I thought that Rust was going to beat it. But yeah, those are our results. That's everything that we learned today. I hope that you guys managed to enjoy this video. It was a bit all over the place, but this is the first time I'm kind of doing like a production, I suppose, style video. And not just one take. He's editing now. Oh my gosh, right? But I really hope that you guys enjoyed this video. Link to all the code will be in the description, as well as, like we had in the beginning of the video, that stuff with Lux Algo. So if you guys are into any of that stuff, it will all be in the description. I hope that you guys enjoyed it. I hope that you guys are excited for new content. Comment stuff below, and yeah, I'll see you guys in the next one. Bye.